So the last topic in Module 2 is community ecology. And basically what we're going to be talking about for this topic is types of species interactions, how they work, and what are some of the common phenomena that we see in different species interactions. So the first video is just going to introduce the types of species interactions and then go into a little bit of depth for competition, and then we'll talk about predation and symbiosis for the second video. So we've defined community before, but we're going to define it again because community interactions and species interactions are pretty much the same thing. If you remember, a community is different populations of different species interacting with each other in the same environment. So species interactions, if species are interacting with one another, that means they must be in the same community. So a good example of a community interaction is a food web. Food webs are based on a particular type of interaction, which is typically predation or herbivory, or something about organisms consuming other organisms. Okay, so that's just one type of community or species interaction, but we're going to be talking about several different ones. So the three main categories are competition, then there's predation / herbivory. We're not really going to talk much about herbivory, but it's sort of meets a similar set of criteria as predation. And then we're also going to talk about symbiosis, and there's three subcategories of symbiosis: mutualism, commensalism, and parasitism. A really easy way to define species interactions is by looking at the effects of the species that are interacting with one another. So these are not in the same order that the last slide was, but I'm going to go ahead and talk about them in the same order. So competition, I believe, was the first one that I mentioned on the previous slide. And one way that you can define competition is that individuals from two different species are interacting with one another, and both of those individuals have negative consequences from the interaction. So I'll define competition again in the next slide, I think, but basically competition is when two individuals are seeking the same resource. That resource can be lots of different things, but because of that interaction, both of them suffer some negative consequence. It doesn't have to be a huge negative consequence, but because of the competition, there is a negative consequence for both the participants. In predation, if you want to define it in terms of the effects on the different species involved, one species involved in predation has a positive effect and one has a negative effect. Species 1 is benefited, species 2 is harmed. Obviously, the species that is benefited is the predator, and the species that is harmed is the prey. And again, we'll talk about the other forms of definitions of that a little bit later. And then we have symbiosis, and mutualism, commensalism, and parasitism all fall under symbiosis, and we'll talk about why that is in just a few minutes. But in mutualism, you have species interacting, individuals of two different species interacting, and both of them are getting some positive benefit from that. Both species 1 and 2 are benefited. There are so many examples of mutualism, and I'm only going to be able to talk about one or two of them. Commensalism is when one species is benefited, but the other species is neither benefited nor harmed, so they don't really care that they're having this interaction. One species gets a positive benefit, the other one gets nothing from the interaction. And finally, parasitism is another form of symbiosis, and it's similar to predation or herbivory in that one species is benefited and the other one is negatively affected. So in that case, the parasite would receive the positive benefit and the host would be negatively impacted. So like I said, we're going to spend a little bit of time talking about competition for this video. And I've given you a similar definition, but you can write down this one. This is sort of more official. Competition, two or more individuals attempt to gain access to the same limited resource. All competitors suffer some costs. So this part of the definition has to do with the last slide where both individuals, species 1 and species 2, are suffering some costs. Now one thing, or both of them have some cost or a negative impact. One thing that was not clear in the last slide, I said species 1 and species 2, but competition can also occur between individuals of the same species. So there's really two categories of competition: interspecific competition. Interspecific competition means competition between individuals of different species. Okay, so that's interspecific. One way I remember that, I don't know if you all are aware of this, but the word inter means between. So interstates are highways that go between states, connect different states together. Intra means within, so you might have heard of intramural sports. That means teams within a specific college are competing within that same college, different teams within the same college. So if you can remember those hints, you might be able to remember that competition, interspecific competition, is between individuals of different species, and intraspecific competition is between individuals of the same species. And so that can occur as long as the individuals are attempting to gain access to the same resource. Both of those things count as competition. Down here we see two, I'm not sure what kind of ungulates these are, but they're some African ungulate, and they are fighting, two males fighting possibly for access to a female, but they are definitely of the same species. So that would be intraspecific competition. Here you have a lion fighting with hyenas, probably over a food source like a carcass. That is interspecific competition. Two different species fighting over the same resource. Now, the resources that lead to competition can be extremely varied. So individuals can fight over food, water, mates, shelter, or any other resource that they need for survival or reproduction. One pretty important concept in competition is called competitive exclusion. In competitive exclusion, this is definitely between two different species. So competitive exclusion is an example of interspecific competition, or can only occur within interspecific competition. This is when you have two species competing for the exact same resources. And the idea is that if you have two species competing for the exact same resources, they cannot stably coexist. One is always going to outcompete the other. So in competitive exclusion, if you have two species trying to gain access to the exact same resources, one species will always win and the other species will always go extinct, or at least locally extinct wherever these two are competing. So here's a classic experiment with two species of paramecium. Paramecium are single-celled protists. You probably have studied these a little bit before. Like I said, they're small. They're single-celled organisms, and they eat bacteria. So here, this graph right here, it doesn't show the exactly the density, but they're just showing sort of like when these two cultures, when paramecia are kept in single species cultures, they exhibit sort of increase in population, and then they reach some stage, and then they sort of have stable population right here. Okay, so this is over time, and over time, if you put like a couple of paramecia of P. aurelia, the population's gonna grow, and eventually it's gonna stabilize. Same thing happens if you put P. caudatum in a petri dish by itself with a bunch of food. It's gonna grow and then it's gonna stabilize. Okay, so but when you put those cultures together in a single petri dish with the same resources, then they both eat the same bacteria. So what you have is P. aurelia does pretty well, and they actually end up reaching some kind of high density population, whereas P. caudatum starts to compete, but then looks like P. aurelia does a better job of competing, and P. caudatum goes extinct. Whoops. So here's another, it's basically the exact same experiment, but it's showing the numbers. So here's P. aurelia alone. Again, you've got this population growth, and then they're doing pretty well by themselves. P. caudatum, population growth, doing pretty well by themselves. And then here, when you put them together, aurelia does relatively well, and caudatum goes extinct. Now, one of the things I want you to notice is, remember that competition, even though there's competitive exclusion here, part of the premise of competition is that both species are negatively impacted. So how is P. aurelia negatively impacted when it is put together with P. caudatum? See if you can figure out what's going on, how you can tell that they are negatively impacted by looking at this final graph and comparing it to this graph. Okay, if you don't notice yet, I'll just point it out. When P. aurelia is in competition with P. caudatum, even though it's a much better competitor, it reaches this equilibrium population size of about 225. Okay, that's when it is competing. When it is alone, it goes up to about 275. Okay, so it can have a higher population when it's not competing with P. caudatum. It reaches a pretty high population here, but it's not as high as it was when it wasn't competing. So that just shows you, and clearly P. caudatum has a negative impact, but P. aurelia also has a negative impact. It's just not as strong as the impact on P. caudatum. Okay, so if that was a little bit confusing for you, please hold on to that and put it down as your muddiest point. That is the end of this first video. In the second video, we'll be talking about predation and the different types of symbiosis.